Hello everyone. Welcome to part 1 of Learn Through Challenges series. This series is aimed at learning or refreshing topics through challenges. If you are watching this is how I would recommend you to proceed in order to gain maximum benefit out of this. First, I'll be explaining the challenges involved. After that, I'd recommend you to pause this video and attempt to solve it on your own. Regardless of whether you could solve it or not, I'd then recommend you watch the solution provided simply because there is no one way to solve it and you may get valuable insights on a different approach. At the end of this notebook, I've given expected answers so that you can validate the accuracy of your code. With that being said, let's dive in. Challenge 1 is this. Create a class named circle which takes in radius as argument and has the following methods: diameter of circle, circumference of circle, and area of circle. So as you can see, Learn Through Challenges part 1 is basically class creation. Challenge 2 is to create a class named cone and which takes in both radius and height as argument and has the following methods: volume of cone and surface area of cone. And challenge 3 is to create a class named line which takes in 2 points, that is x1 y1 and x2 y2 as arguments and has the following methods, that is distance between these points and the slope of the line formed. And you can see that we have expected answers, so we'll put in these values and make sure that you get the same answers that is being provided here. Now let's start with challenge 1. So since we are using distance as well as pi, we are starting with importing math. So let's import math. Then let's create the class named circle. Class circle. Okay, let's start with the documentation. What do you want with this class? Okay, the class circle takes in radius as argument and has methods to calculate diameter, circumference, and area of the circle. So that's all about documenting the class. Now let's start with defining the constructor. So define init self and it takes in radius. Now self dot radius is equal to radius. Now let's define diameter. So self. So what does this do? Now let's copy this diameter of circle. Okay, diameter of circle is 2r. Now dia is equal to 2 times self dot radius. And now let's return this. Return, and what we are trying to do is we are trying to create an f-string literal. The diameter of the circle for the given radius, and that is dia. Okay, now let's define. We are going to define the circumference. So define circumference. Let's document that. So circumference of a circle is equal to 2 pi r. So circum is equal to 2 into, we are going to import pi from the math into self dot radius. Now let's return this. The circumference of the circle for the given radius is equal to circumference. Okay, now let's define area. Let's document that. Area is equal to pi r square. So since we cannot actually mention whether it's centimeters, meters, or whatever unit it is, what we'll do is we'll just write this as units. So whatever unit we are giving for radius, the corresponding unit you'll get. So this is area of the circle, so pi r square unit square. Okay, now again area is equal to math.pi into self dot radius square. Now let's return this. Return again f string literal, the area of the circle for the given radius is equal to area. Okay, now that's it. So we have actually defined the class circle. I'm just removing the trailing white spaces. Okay, let's run this. Now let's try it out. We're going to create an instance for circle. Now let's write circle 1 is equal to circle, and this is the beauty of documentation. If I press shift tab, you can see that we have a documentation. Let's see that circle takes in one argument, and that is radius, And what is this all about? The class circle takes in radius as argument and has methods to calculate diameter, circumference, and area of the circle. Okay, now let's put a value of 10 because that's what we have given here. Circle with radius 10. I'm giving 10, and let's find out what is the diameter and so on. So if I press dot and press tab, sorry, it's circle 1. If I press tab, you can see that we have three options: area, circumference, and diameter. Let's start with the diameter. Now let's print this out. Okay, so print. Now let's print circle 1 dot circumference, and these are methods, which means that we need to end it with parenthesis. Now let's find out area also. So circle 1 dot area. Now let's run this. You can see the diameter of circle for the given radius is 20. So since we have given 10, it's correct. Circumference is 62.83 and area of a circle is 314.159, which can be approximated to 16. So if you cross check the answers, you can see the 20, 62.83 and 314.16, which means that we have successfully created a class for circle. Now let's move on to challenge 2, where we create a class named cone. So let's start class cone, and again let's start with documenting this. So the class cone takes in radius and height as arguments and has methods to calculate the volume and surface area of the cone. Okay, that looks good. Now let's create the constructor, and as mentioned, it takes in two parameters, radius and height. So let's write self dot radius is equal to radius, self dot height is equal to height. That looks good enough. Now let's look at the volume method. When volume of self, let's first document that. So volume of cone. So volume of cone is basically pi into r square into height divided by 3. So let's write volume is equal to pi, which is math.pi. You can put 3.14, but I prefer the actual value of pi, the full value of pi, rather than 3.14. So into, we need r square, which is self dot radius square, into, we need height by 3. So self dot height by 3. That looks good enough. Let's return this. Return the volume of the cone for the given radius and height, that is wall. Okay, now let's define surface area which takes in self. Let's document this. The surface area of a cone, a slightly tricky equation. Now what this equation is all about, you can see that we are actually multiplying, we are actually having two parts. One part is pi into r, and we are multiplying this pi into r with r plus square root of h square plus r square. So what we are going to do is, for simplification, we are going to split this into two parts. So let's split this into part 1, which is basically pi into r, and part 2 is equal to, let's copy this. So r plus square root of h square plus r square. Let's actually write the function. So we're going to write again as whatever written above. We're going to define part 1 and part 2. So part 1 is equal to pi into r, which is basically math dot pi into r, which is self dot radius, and part 2 is equal to, let's put it in parenthesis, self dot radius plus its square root, which is again taken from math. So math dot square root of, we need h square plus r square. So we're going to put like this, plus, and that's for r square. So let's put here as h square, which is self dot height square, and this is self dot radius square. Now let's make sure that we put all the parentheses properly. You can see that, how do you identify that? You can see that this is green and the corresponding green will be highlighted. So this is correct, and this is for this one, square root, and that looks okay. Now we need one more, which is here, the outer one, which is correct. So this means that we have done it properly. So surface area is equal to basically part 1 into part 2. Now let's return that. So return, again we put an f string literal, the surface area of the cone for the given radius and height, that is so area. And that's it. That's all about cone. Now let's remove the white spaces. Now this is a good practice. if you're basically scripting this, we have to make sure there are no trailing white spaces. Okay, now that looks good enough. Now let's run this, and now let's create an instance of cone. So cone1 is equal to cone. Again, let's try shift tab. You can see that takes in radius and height and has methods to calculate the volume and surface area of the cone. Now let's do that. So cone1 dot, if you press tab, you have surface area and volume. Let's start with volume. Again, remember that this is a method, so let's print this out, and again print cone1 dot surface area. That's also a method. Now we need to give a value. So for this we are giving a radius of 1 and height 3. So just press shift tab to know that's proper order. So radius comes first and height comes second. If you want, you can simply start writing like that. So if you want, you can write radius is equal to 1, just to make sure that it's properly assigned. Height equal to 3. You run that. Volume of cone for the given radius and height is 3.14. So that's basically 3.146, something related to that. And surface area is 13.076. Now let's check this. So volume is approximately equal to 3.14 and surface area is approximately equal to 13.08. So 13.076, which can be approximated to 13.08. And now that looks good enough. So we have successfully created the cone class also. Let's finally do the line class. So let's start class line. Now what do you want this? Basically the class line takes in 2 points x1, y1 and x2, y2 as arguments and has methods to calculate the distance between the points and the slope of the line formed. Points and the slope of the line formed. That looks okay. Now let's create the constructor. So define init self, and it takes 2 points. So let's write it as point 1 and point 2. And self dot point 1 is equal to point 1 and self dot point 2 is equal to point 2. Now let's define distance. Distance, it takes in self. Sorry, we need to document this. So let's just copy this. So distance between points is basically square root of x2 minus x1 square plus y2 minus y1 square. That's what we are going to do. Now before that, we have to remember that we are taking in points as a tuple. So this point 1 is basically a tuple of x1, y1, and point is also a tuple of x2, y2. So we need to unpack this tuple in every functions, that is for both distance as well as for slope. We need to unpack this. So that is the first step. So x1 comma y1 is equal to self dot point 1 x2 comma y2 is equal to self dot point 2. Okay, since we have unpacked this, we can write distance is equal to math dot square root of, we need x2 minus x1 whole square plus y2 minus y1 the whole square. Now this, I'm going to put it again like this. So this is basically x2 minus x1 the whole square, and this is y2 minus y1 whole square. So let's just confirm that it's properly parenthesized. So this comes to this, that looks okay. This also looks okay. Similarly, this looks okay. It may not be clear for you, but for me, when we highlight this, you can see the color change from black to green. Let's finally highlight this. Yeah, that looks okay. Now let's return this. Return. We're going for the same format, that is an f string literal. So the distance between points given, and that is dist. Now let's define slope, which also takes in self, and let's copy this for documentation. So slope is basically y2 minus y1 by x2 minus x1. Again, we have to remember that we had only unpacked inside this function, which means that x1 y1 x2 y2 is not available for this function. Okay, the scope of this unpacking is inside this function only, so we need to unpack this again. So let's just copy this and let's just paste here. Now we are going to write as basically slope equation. So slope is equal to, let's just write y2 minus y1 divided by x2 minus x1, and let's return that. Return the slope of the line formed by 2 points, that is slope, and that's it. So let's just check for white spaces. So I'm just removing the trailing white spaces. Okay, that looks good enough. Now let's run this and let's test this. So we are going to create an instance of line. So let's make it line 1 is equal to line plus shift tab. So it takes in 2 points, point 1 and point 2. Class line takes in 2 points, x1, y1 and x2, y2 as arguments, and as methods to calculate the distance between the points and the slope of the line formed. So let's give in 2 points. 2 points that we're giving is 9, 2 and 15, 10. So you have to make sure this is a tuple. So first one is a tuple which takes in 9, 2. So x1 is 9, y1 is 2, and another one is 15, 10. So x2 is 15 and y2 is 10. Just make sure this is correct. Okay, now let's find out the distance. Again, this is a method and I need to print this out. So print and let's find out the slope also. Line 1 dot slope, that's also a method. So let's run this and see the distance between point given is 10 and the slope of the line formed by the 2 points is 1.33. and see that distance is 10 and 1.33. So we have successfully created a line class also. So the aim of this tutorial, or rather the challenge, was to practice or get used to creating classes. So with that we come to end of this session. Thank you.